Welcome back. In this section, we will discuss about do you know the top 5 secret of performance tuning in Apache Spark? Here are the top 5 secrets of performance tuning in Apache Spark, keeping in the mind that the best secret can sometimes depend on the specific workload and environment. But these are general consideration, fundamentals and highly impactful. First one is data partitioning and distribution are key. This is arguable the most crucial aspect of Spark performance tuning. Spark operates on distributed data, and how the data is partitioned across the cluster significantly impacts processing speed. Right number of partition. Having too few partition can lead to underutilization of cluster resources, while having the too many can result into exce- excessive task scheduling overhead. Aim for a number of partitioning roughly equal to the number of cores in your Spark cluster. You might need to adjust this based on the stage of your pipeline. Avoid data skewing. Data skew occurs when data is unevenly distributed across partitions. Task processing large partition will take significantly longer, creating bottlenecks. Analyzing your data distribution and use techniques like sorting, broadcasting, smaller dataset, or repartitioning strategy to mitigate skew. Partitioning strategies. Choosing partitioning strategy that align with your query patterns. For example, partitioning by date can speed up time based queries. However, be mindful of high cardinality columns for partitioning as they can lead to many small partitions. Second, optimizing and joins and shuffles. Shuffles are expensive operation in Spark as they involve data redistribution across executor. Efficiently handling joins and minimizing shuffles is critical. Broadcast join. For joining a large data frame within a significantly small data frame using broadcast join. Spark.sql.auto broadcasting join threshold. This sends a copy of the smaller data frame to each executor, eliminating the need of for shuffling. Reduce joins. When joining large dataset, ensure the joining keys are properly indexed or partitioned. Filtering data before joining can significantly reduce the amount of data that need to be shuffled. Avoid unnecessary shuffles. Operation like distinct and certain aggregation trigger shuffles. Try to optimize your logic to minimize the operation of performing them on the smaller dataset if possible. Third one is efficient data serialization and storage. The format in which data is stored and serialized impacts both storage space and the processing speed. Effective effective data format. Prefer columnar format like Parquet or ORC over row based format like CSV or JSON, especially for analytics workload. Columnar formats offer better compressions and allow Spark to read only the necessary columns. Optimize serialization. Spark uses Java serialization by default, which can be slow. Consider using Kryo serialization, which is often faster and more compact. enable it to in your Spark configuration. Compression. Use compression codec like Snappy or gzip for data storage and shuffling. Snappy offers a good balance between compression ratio and decompression speed, while gzip provides high compression but it's slower. Fourth one is resource management and configuration tuning. Properly configuring Spark resources and understanding how Spark allocates them is crucial for performance. Executor memory and cores allow allocate appropriate memory, that is spark.executor memory, and cores, that is spark.executor.cores, to your executor. Too little memory can lead to out of memory errors, that is called and data spilling, while too many cores per executor can increase context switching overhead. Experiment to find out the optimal balance for your workload. Driver memory, increase driver memory, that is spark.driver.memory. If your driver node is handling the large amount of data or performing complex operation. Dynamic allocation. Consider enabling dynamic allocation, that is spark.dynamic allocation.enable, to allow Spark to scale the number of executor based on the workload. This can improve resource utilization. Shuffle configuration. Tune shuffle related configuration like spark.shuffle.service.enabled. Using our external shuffle service can improve stability, and Spark shuffle.partition increase if you are seeing excessive spilling during shuffles. Fifth one, understand Spark execution plan and optimize transformation. Analyze the Spark execution plan, help you understand how Spark is executing your queries and identifying potential bottleneck. Use explain method on the data frame or SQL queries to see the physical and logical execution plan. Look for stages with exclusive shuffles, full table scan where filters should be applied, or inefficiently joined strategies. Optimize transformation. Choose the right transformation for your need. For example, reduce by key is generally more expensive than group by key for aggregation, as it performs pre-aggregation on the mapper side. Caching strategies. Caching intermediate data frame that are reused multiple times using the df.cache or df.persist functions. However, be mindful of the memory usage and unpersist data frame that when they are no longer needed. Avoid operation that moves data to the driver, like operation that uses collect function and take function. Bring data to the driver node when which can be bottleneck for large data set. Use them sparing primarily for debugging or when dealing with small data sets or small result sets. Use native function. When possible, leverage Spark built-in functions as they are often optimized for performing compared to user-defined function, especially those written in Python. If you use UDF, consider using Scala or Java for better performance. By focusing on these five key areas, you can significantly improve the performance of your Apache Spark application. Remember, the performance tuning is often an iterative process that involves understanding your data, workload, and cluster configuration, and then experimenting with different techniques. So that's all for this lecture. See you in the next video.